Hey everyone! Today, we're going to tackle a topic that sounds pretty serious: linear programming. I know, the name itself can sound a bit scary. But trust me, by the end of this, you'll realize it's just a really smart and actually simple way to figure out the best possible solution to some very common problems. So, let's dive right in.
Just think about your own life for a second. Let's say you've got a big exam coming up, but you only have a couple of hours to study. Do you spend all that time on maths, or maybe focus completely on physics, or do you split your time between them? Your goal is to get the best possible marks, right? Well, that's exactly what linear programming is all about. It's called optimization. It's basically making the absolute best choice when you have limited resources, whether that's your time, your money, or even your phone's data pack.
Okay, to make this super clear, let's use an example you'll totally get. Imagine for a second you're a YouTuber, and your main goal, your only goal, is to get maximum clout. We're talking views, likes, subscribers, the whole shebang. You have two kinds of videos you can make: really helpful tutorial videos, let's call those X, and those crazy challenge videos, which we'll call Y. But here's the catch. You can't just make unlimited videos, right? You have limits. In the world of math, we call these constraints. So, for example, maybe you only have 60 hours in a week to edit all your footage. And on top of that, your internet plan only gives you a 100-gigabyte data pack for all your uploads. These are the real-world rules you have to play by. And believe it or not, this brings us right back to your textbook. You know that famous problem about a furniture dealer? The one who wants to make the most profit but has limited money and storage space? It's the exact same puzzle. The YouTuber wanting clout is just like the dealer wanting profit. The limited editing hours and data are just like the dealer's limited money and storage. The logic is 100% the same. Okay, so for any of these problems, the very first step is to clearly define your goal. What is it that you're trying to achieve? In linear programming, this has a special name. We call it the objective function. It's just a fancy way of saying a math equation that describes your main mission. So here's the official definition, straight from your NCERT book. The objective function is a linear function written as z equals ax plus by. Our job is to either maximize this z, like when we're talking about profit, or minimize it, like if we were talking about costs. Now, the x and y here are the most important part. They're called decision variables because the entire answer depends on the values we decide for them. For our furniture dealer, this means deciding how many tables, x, and how many chairs, y, to deal with. Let's break down the dealer's profit. The problem tells us he makes a neat profit of 250 rupees on every table and 75 rupees on every chair. So if he sells X number of tables, his profit from them is 250 times X. And if he sells Y number of chairs, his profit is 75 times Y. Makes sense, right? So the dealer's number one goal, his main mission, is to maximize his total profit. We'll call this total profit Z. And how do we find it? We just add up the profit from tables and the profit from chairs. This gives us our objective function, z equals 250x plus 75y. This equation right here is what we're trying to make as big as possible. Awesome! We have our goal locked in. Now, we need to talk about the rules of the game, the limits. Just like our YouTuber who had limited time and data, our furniture dealer also has some rules he can't break. In linear programming, we call these the constraints. Okay, let's look at the official definition for a second. Constraints are simply the linear inequalities or restrictions that are placed on our decision variables. They're the boundaries that tell us what we can and cannot do. For our furniture dealer, the problem clearly gives us two main limits. First, he has a total of 50,000 rupees to invest. He absolutely cannot spend more than that. And second, his storage space can only hold a maximum of 60 items in total. These are his two main constraints. Let's translate that first limit into a math equation. We know a table costs 2,500 rupees and a chair costs 500. So the total cost for X tables is 2,500X, and for Y chairs, it's 500Y. When we add these two costs together, the total must be less than or equal to his investment of 50,000 rupees. Now, look at that inequality. Those are some pretty big numbers, right? To make our life much easier when we solve this later, we can simplify it. If you notice, every number in there can be divided by 500. So let's do that. What we get is a much friendlier looking constraint. 5x plus y is less than or equal to 100. See? So much cleaner. It's a really useful trick. All right, now for the second constraint, the storage space. This one's pretty straightforward. The dealer can store a maximum of 60 pieces, so the number of tables, x, plus the number of chairs, y, has to be less than or equal to 60. Simple as that. X plus y less than or equal to 60.
Okay, time for a very important common sense question. Can the dealer go and buy minus 10 tables? Or maybe minus 5 chairs? What do you think?
Of course not. That's impossible. You can't buy a negative number of items. This simple idea gives us our last, but super important set of constraints. We call them the non-negative restrictions. It basically just means that x, the number of tables, has to be greater than or equal to 0, and y, the number of chairs, also has to be greater than or equal to 0. This might seem really obvious, but trust me, it's a crucial step, and you have to remember to write it down every single time.
All right, we have all the pieces of our puzzle now. We have our main goal, the objective function, and we have all the rules, the constraints. So let's put it all together and see what the final mathematical formulation of this linear programming problem looks like.
And here it is. This is the complete answer. Our goal is to maximize z equals 250x plus 75y. And we have to do this subject to the constraints. 5x plus y is less than or equal to 100, x plus y is less than or equal to 60, and of course, our non-negative restrictions, x is greater than or equal to 0, and y is greater than or equal to 0. That's it. We've successfully taken a real-world story problem and translated it into a neat mathematical plan. So let's do a super quick recap. For any LPP formulation, just follow these 4 easy steps. 1. Identify your decision variables. What are your x and y? 2. Write down your objective function, z. What's your main goal? To maximize or minimize? 3. Write out all the constraints based on the limits given in the problem. And 4, the easiest one to forget, add the non-negative restrictions. And there you have it. You've just learned the most fundamental skill in this chapter, how to formulate a linear programming problem. You literally took a story that seemed a bit complicated and turned it into a clear, simple plan using math. That's a huge first step, so you're doing absolutely great. Keep practicing this and you'll become a pro in no time.